This is question number 7 on homework 5, problem 5-16. Miller Corporation has a premium bond making semi-annual payments. The bond has a coupon rate of 11%, a YTM yield to maturity of 9%, and 11 years to maturity. The Modigliani Company has a discount bond making semi-annual payments. This bond has a coupon rate of 9%, YTM of 11%, and also has 11 years to maturity. Both bonds have a par value of $1,000. So one bond is a premium bond, another bond is a discount bond. Premium bond means that the price is higher than the par value, and discount bond means that the price is lower than the par value. Based on the 4 important relationships on bond valuation, especially the second relationship, we should immediately realize that Miller Corporation, the price, because the price is higher than the par value, so the yield to maturity has to be lower than the coupon rate. And that's exactly the case. And for the other company, it's the other way around. The yield to maturity should be higher than the coupon rate, hence the price is lower than the par value. So the first part of the question is, what is the price of each bond today? So this is a very standard bond valuation question. We just need to do multiple calculations based on different requirements. First part is about the price of each bond today. So I would like to use Excel to solve this problem. So Miller, first company is Miller Corporation, and we just write down the information. So the coupon rate is 11%, but we should realize setup tells us this is a semi-annual payment, so we should work with semi-annual numbers for each variable. So that means the coupon rate 11% means that the annual coupon payment is 11% multiplied by the par value of $1,000. That's $110. So we should divide that by 2 to get to the semi-annual coupon payment, which is 55. So the semi-annual coupon, that's 55. And the second variable we need is the YTM. So any information by default provided is the annual number, but as we said, we should work with the semi-annual numbers, so we should also divide the YTM here by 9%. Divide YTM of 9% by 2, so that gives us the semi-annual YTM, which is equals 0.09 divided by 2. And yields to maturity is 11 years for Miller. Again, we have to work with the number of semi-annuals, which is 11 multiplied by 2, 22. Par value for both is 1,000. So we can use the PV function, Excel. Let me make this bigger. So price equals PV, present value of rate. Rate here means the discount rate. And the discount rate in this case is the semi-annual YTM. So that's the 4.5%. And this NPER is the number of coupon payments, and it's the B2. And this PMT here is the coupon payment, semi-annual coupon payment. Oh, sorry, actually the NPER is the number of payment. That should be the 22 number of semi-annuals, not 55. The third argument, PMT, should be this semi-annual coupon payment. And finally, the FV here is the future value. In this case, it's the par value. And we have a negative number here is because we put positive payment and positive par value. If we want to make the price to be a positive number, then we can set the payment and the par value to be negative. So you can see that the absolute values will not change, but the sign will change from negative to positive. So price is for the rounding requirement. Do not round intermediate calculations, round your answers to 2 decimal places. And that's exactly what we did. Otherwise, you have to change the format of the Excel and to make it to be consistent with the rounding requirement. So 1137.84. And price of Miner, price of Modigliani. The procedure is the same, so I just copy and then I just change the number. Now Modigliani is a discount bond. The coupon rate is 9%, so this becomes 45. And semi-annual YTM, that's the 11%. So this will become 11 divided by 2. And you can see this becomes 5%. That's because, I guess that's because the decimal places was kept to be 2. So if I want to make this to be, actually, there's a typo. This should be 11% divided by 2. So now it's 5.5%. And 11 years to maturity, it's the same for both bond, and par value is the same. So I can just copy actually. You can see it's Excel automatically uses the new information to calculate the current price. So the current price for Modigliani is 874.17. So that's the first part of the problem. Let's continue. If interest rates remain unchanged, what do you expect the price of these bonds to be 1 year from now? In 2 years, 6 years, 10 years, and 11 years. So here we just we need to do similar calculations for actually here for each bond 5 more calculations. But calculations will be similar to what we have done so far, but we just need to change some information. The specific information we need to change is because the question asks us what will be the price of the bond 1 year from now. So that makes everything else stays the same. So what will change? Let's see. Coupon rate will not change, and the setup says the interest rate does not change, so the semi-annual YTM doesn't change. But obviously the maturity will change, right? 1 year from now, the maturity will decline by 1 year, and 2 years from now, the maturity will decline by 2 years. So this last on the par value will not change. So this semi-annuals, number of semi-annuals will change. And 1 year from now, because the initial years to maturity is 11 years, so 1 year from now, the remaining years to maturity is 11 minus 1, which is 10 years, and that makes the number of semi-annuals to be 20. So let's change this number to be 20, and you can see that Excel will automatically calculate the new price based on the new numbers. So let's just fill in this blank. Now the price 1 year from now will be 1,130.08. And for Modigliani, it's the same. We just change this to be 20, and that makes the price to be 880.50. Again, the rounding requirement, round your answers to 2 decimal places. So that's exactly what we did. And 2 years from now, we just need to change this to be 18, because 2 years from now, the remaining maturity will be 9 years for Miller Corporation. So that makes the number of semi-annuals to be 18. And same for the Modigliani. So the price will be 1121.0.8, 0.60, and price for Modigliani will be 887.54. And similarly, 6 years, after 6 years, initial maturity was 11 years for Miller. So after 6 years, the for both actually, for both companies, the initial years to maturity is 11 years. So after 6 years, the remaining maturity will be 5 years. So that makes the number of semi-annuals to be 10 for both. 10. So this is 1079.13, and 6 years for Modigliani, 924.62. And after 10 years, this will become, the remaining maturity is only 1 year. So that makes the semi-annuals to be 2 for both. 2. So so what's the 11? Yeah, 11.984, 981.50.54. So finally, after 11 years, so after 11 years, the bond matures. So when the bond matures, the only final remaining payment is the par value. So that means nobody is going to pay a higher price than the par value, and nobody is also going to pay a lower price, because that's just a pure windfall, and the market doesn't allow for that. So after 11 years, the price of Miller has to be the par value, and for Modigliani, it's the same. So now let's check our work. Okay, great. We got all the calculations correct.